Alright, welcome again to the channel. It's always a pleasure to have you back here. I'm Pendulum, as you already know, and I'm your tutor on this channel. This is Pendulmatics, and all we do here is mathematics. Alright, so welcome back. We are still on number-based systems, but we are at the end of this topic. So this is the last video on this topic, and in this video we are going to look at equations in different number bases. So we'll round up with this and we'll move to another topic. So if you're new here, you're welcome. Do consider subscribing to the channel and turn on the notifications bell. Just ring that notifications bell so that whenever there's a new video up on the channel, you'll be notified to come and watch and learn something new. Alright, so we'll go into the video quickly. As we go on, if you find the video helpful, do remember to like the video and drop your comments so that I know exactly what you like about the video and what your thoughts about the video is. Alright, finally, don't forget to share this video with your friends, with your fellow students, with your children. Share it wherever you can to help as many people as possible. Alright, so come with me, let's get started. We have 3 questions here, so I believe these 3 should be able to give us a very good understanding on how to deal with equations that appear in number bases. So number 1, we are told that 23 base x is equal to 1111 base 2. We are meant to find x. Now this is an equation because wherever you see an equality sign between two mathematical terms, it becomes an equation. So when it has a left hand side and a right hand side separated by an equality sign, it becomes an equation. Equation is from equality sign. Alright, so here we are meant to find x. Now if you look at this question, the first thing you will notice is that they are in different bases. This is in base x, 23 is in base x, and then 1111 is in base 2. This is a binary number. So to be able to solve this and find x, virtually the only thing you can do here is to try to convert both of these numbers in their respective bases or from their respective bases to base 10. Alright, so that's what we're going to do. We're going to convert both of them to base 10, and we do that by expansion. We've already covered that in a previous video. So if you still are not clear with how to convert from one base to base 10, you can go watch that video before you come back and continue. But simply, this is 0, 1, this is 0, 1, 2, 3. Okay, so we expand both sides. Now this side is going to give me 2 times the base raised to the power 2 times x raised to the power 1 plus 2 times x, the base again, 3 times x raised to the power 0. That's for this left hand side. 2 times x raised to the power 1 plus 3 times x raised to the power 0 is equal to, on the right hand side again, 1 times the base raised to the power 3 plus 1 times the base 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. So if you're able to expand both of them like this, you're already almost at the home stretch, because if we work on this, we'll get here that x raised to the power 1 is x, so we have 2 times x, which will give us 2x. Then x raised to the power 0 is 1. Any number raised to the power of 0 is 1. Alright, so 1 times 3 is 3. Okay, then on this other side we have 2 raised to the power 3 is 8. 2 times 2 times 2, 8 times 1 is still 8. 2 raised to the power 2 is 4. 2 raised to the power 1 is 2. And I just told you anything raised to the power 0 is 1. So you have this, which is a very simple linear equation. I can still have that 2x plus 3 is equal to, if I add up this side, 8 plus 4 is 12. plus 2 14 plus 1 15. All right, then I collect like terms. Simply plus 3 is going to move to the other side. Why? These two are numbers, so they are like terms. Plus 3 and 15 are numbers, so both of them are alike. They are like terms. And remember that if plus crosses the equality sign, it becomes minus. So I have 2x is equals to 15 is already here, so I put it down here. Plus 3 crosses, it becomes minus 3. 2x is equal to 15 minus 3 is 12. Now to find x, I have to get rid of these 2. So I divide here by 2. I divide here by 2 so that 2 can cancel out itself. Alright? And then if 12 divided by 2, we get 6. So x is equal to 6. Okay, so this is quite straightforward. Once you're able to expand it, you find out that it's quite straightforward. If you want to prove your answer, 23 in base 6, if you convert it to binary, you should get 1111. Alright, so you can try that. 23 in base 6, convert it to base 10, and then convert it to binary. You should get 1111. Alright, so that's that for number 1. Quite straightforward actually. The only issue here is just expanding by conversion to base 10. If you're able to convert to base 10, then you do not have any issues. So let's look at the second one. We are told that 25 in base n is equal to 102 in base 5. Well, we are meant to find n. Same process, convert to base 10. And we still convert again by expansion. So it's like a repeat of what we did here. Alright, remember 0 is the first digit. That's what on top of the first digit, the other one is 1. If there's another digit, it will be 2, 3, 4, like that. The same thing here, 0, 1, 2, 3, 4, like that. So if we expand, this times the base, 2 times n raised to power 1 plus 5 times n raised to power 0 is equal to, on this other side, we'll do the same thing, 1 times 5 raised to power 2 plus 0 times 5 raised to power 1 plus 2 times 5 raised to power 0. Then all we have to do here is to simplify. Okay, 2 times n raised to power 1 is n, so 2 times n is 2n. Anything raised to power 0 is 1. 5 times 1, 5. 5 squared is 25 times 1, 25. This is 0, so we can ignore it. 0 times 5 is 0. 5 raised to power 0 is 1. Any number at all raised to power 0 is 1. And 1 times 2 is 2. Okay, so this is what we have. Again, just like here, simple linear equation. So let me add up here first. This is 27, right? So again, we'll collect like terms, plus 5 will cross over to this side. So this is 27 minus 5, because when plus 5 crosses, it becomes minus 5. This is very elementary mathematics. So I have that 2n is equal to 22. Now I want to get n. We're asked to find n, not 2n. So we need to remove this 2. How do we remove it? We divide here by the 2, divide here by 2. So that 2 can cancel 2, leaving you with only n. And if you divide this, you get 11. So this is our answer, that n is equals to 11. So quite easy, quite easy. Okay, so let's take the last one. This video will be a short one, thankfully, because some of our videos have been quite long. So we have to calculate for p if 53p plus 41p minus 25p is equal to 63p. Okay, we're asked to do this. Let's see how we can do this. Same process always. Convert all to base 10. Convert all the numbers here. We're going to convert all the numbers here to base 10. We do that. 0, 1, 0, 1, 0, 1, 0, 1. Okay, so that means this will give me 5 times p raised to the power 1 plus 3 times p raised to the power 0 plus 4. Now I'm here. 4 times p raised to the power 1 plus 1 times p raised to the power 0. Then we're here now. Minus, let's put this one in bracket because it's minus. Let's put it in bracket. 2 times p raised to the power 1 plus 5 times p raised to the power 0. Then everything is equal to, if we expand here too, we have 6 times p raised to the power 1 plus 3 times p raised to the power 0. So just carefully expand all of them one by one. Carefully expand all of them one by one, and the expansion is the number times the base raised to the power on top. Alright, so each number times the base raised to the power on top of that number. So let's go on. Now, p raised to the power 1 is p. P times 5 is 5p. P raised to the power 0 is 1. 1 times 3, 3. Now, this is p raised to the power 1, p times 4, 4p. P raised to the power 0 is 1. Any number raised to the power 0 is 1. 1 times 1, 1 plus, okay, minus bracket. P raised to the power 1 is p times 2, 2p plus p raised to the power 0, that's here. P raised to the power 0 is 1. 1 times 5, 5 is equal to p raised to the power 1 is p times 6, 6p plus p raised to the power 0 is 1. 1 times 3, 3. Alright, so for this side, this first slide, let me rearrange it to make it clearer. Or no need, this is elementary maths. 5p plus 4p is 9p. Okay, 5p plus 4p is 9p. Then 3 plus 1 is 4. This is elementary maths, so let's not waste time on it. 5p plus 4p is 9p. 3 plus 4 is 1. Sorry, 3 plus 1 is 4. Then, if we open this bracket, minus times 2p minus 2p, minus times plus 5, minus times plus is minus 5, equals to 6p. Let me write it in a way that it will enter, please. So this is 9p, 5p plus 4p plus 3 plus 1, 4, minus 2p, minus times plus 5, minus 5, 6p plus 3. Okay, now 9p minus 2p is 7p. 4 minus 5 is minus 1. 6p plus. This is just linear algebra. Very, very elementary. Okay, so now we want to collect like terms. If you look at this side, we have 7p, 6p. Both of these are like terms. Minus 1 plus 3. Both of these are like terms. So I can bring 6 this way, bring minus 1 this way. Okay, and remember, if -1 crosses, it becomes +1, and if 6p crosses to this side, it becomes -6p, because 6p is positive. So when it crosses, it becomes negative. Now 7p is already here. I just write it down. 6p crosses, it becomes -6p. 3 is already here. I just write it down since it's already there. -1 is crossing to come and meet it, so it becomes +1. Now 7p minus 6p is p. 3 plus 1, 4. So this is our answer. P is equal to 4. So quite simple. Quite simple. Alright, so if you have any questions or any part of this is not clear, as always, you can drop it in the comments. But I believe this is very basic and this should be very, very clear. Okay, so finally, let me just give you an assignment and we'll round up on number basis. Okay, so yeah, so this is your assignment. Just 2 questions. I know I keep giving you this assignment so that you try your hands on these questions, see how well you've understood whatever topic we just done. And I keep encouraging you to share your answers with me on WhatsApp, on Telegram, in our Telegram community, or on YouTube here in the comments or wherever. So number 1 says if you're given that 126 in base x is equal to 86 in base 10, find x. Now, a little hint I'll give you. In this case, this question is a bit simpler because 86 is already in base 10. You don't have to do any conversion again. 86 is already in base 10. So the only thing you have to do is convert 126 in base x to base 10 by expansion. Whatever you get will be equal to 86 on the other side. Alright, so you're not doing any other expansion for 86. Okay, so that's important that you take note of that. You're not doing any other expansion for 86. Just expand this one, then equal to 86. You find your answer. The number 2 is the same thing as this. So just expand all of them. Expand this plus expand this minus. Please, when you do the minus, remember to put in a bracket, because when you open up the bracket, the minus will affect this plus inside. So if you don't put the bracket, you will miss out on that and you'll be having a wrong sign here. So when you are doing the minus, wherever you come across minus in mathematics, always, and you are substituting, always remember to put a bracket, please. Alright, so you expand this one and you expand this one as well, all to base 10, and then you just solve it like we solved this third one. Alright, so that is this for this video. Thank you for being here. I hope you found it helpful. I hope you learned something. If you did, don't forget to like the video, drop your comments. I always love reading your comments and hearing how this channel and the videos are helping you with your mathematics journey. And share this video, very, very important. Let other people see and learn from the videos. Let them also enjoy what you're enjoying. So share it on your status, share it with your friends, share it in your class groups, share it wherever you can share. Alright, so thank you. We'll be going into a new topic set in our next videos. So get ready for that. Spread the word. Get your friends to come and join us here. Alright, if set was a problem for you in school, or if set is a problem for you in school, then we'll be trashing it and breaking it down from the next few videos. Alright, thank you so much. I will see you some other times. Keep learning, keep studying. I am Pendulum. Goodbye for now.